object recognition is a nice option. We should detect something and um, maybe use that for some kind of purpose. Like it detects a cup, so that it can take it. So that's a good feature it should have. What else you can think? Somebody was
Being able
talking.
to
Yeah, tell
hello?
me.
Being able to like understand points in 3D space to
Hmm.
like
That's like
understand.
yeah, yeah. So this is like mostly related to navigation part, I guess. Like it should detect something in 3D, like but like there is a chair. It should
Yes, yes, yes. Like it should be able to understand the like on the three axis to exactly like position hand according to the object on the shelf or where from where it is picking or from where it is placing the object.
Nice, nice, nice. Yeah, it should have that idea. Yeah. So and there are few. Somebody was talking about Ultron. Yeah, it should say Ultron. We can say it's like LLM these days. So it should understand what people are saying. It should be able to do the task what uh, uh, that person has to do, right? So
Sir, working as a soldier.
working as a soldier, nice idea. So what does a soldier do? Like apart from war, like there are more other things we can do with robots.
Implement
Uh,
like target
Insert,
aiming and like, the idea of
inserting
being
inserting weapons in it.
Yeah, there could be some kind of manipulation. Like it can, if a robot can take a pillow in its hand, it can take a missile also. So this could be something. But like for this application, I'm talking about something like house daily use app. What the features it should have. Uh,
Being
Sir,
able to give haptic feedback, like
yeah,
whether
nice
the
one.
object is heavy or not,
sir,
whether it is brittle or something like
Mm.
that.
Yeah, so some kind of touch, it should be sensitive to touch, and it should give a feedback to the person, like wherever it's touching, right?
Being able to understand temperature like the hotness and coldness, temperature
Mm-hmm.
measurement.
Nice, nice feature. So if you are handling like tea, it shouldn't be too hot or too cold. So it should be one of the main features for this application. Yeah, so just to summarize, like we have put up so many ideas. We have like uh, few features, like it should be able to see things. It should be able to detect things, like there is a cup or something like that. It should be able to navigate, like there is an obstacle in front of it, and there is a 3D space. It should be understand. It should understand that and move, and it should have some kind of touch sensitivity. It should understand like if a person is touching it, or like when it is touching a person, it should give a feedback. And it should have some language interface, like so that people can just talk to it and bring like do some stuff, right? So these are like really good ideas, but the question is how we are implementing it. Like for image, like we can have put up a camera. For 3D navigation, we can put up a lidar. So lidar is like a sonar, but it works mostly in the using the light, and like the image recognition, object detection, it's an algorithm type of thing. So it should have some kind of that, and there should be some level of control also, so that like robots should move. So to move, it should be able to control the motors on the wheel, or like legs, whatever you are attaching it. There should be a some kind of control, and there should be a smart algorithm to give the robot the level of its surrounding. It should be able to do all of this, right? You can put like so many sensors, uh, whatever you can imagine. Hey, if you have unlimited budget, you can put whatever with this robot. Okay, as in it. I'll show you an example of a robot, which is similar, kind of similar to what we were looking for. This is like Tiago. So I'll show you. The task was to design a robot which could give a level of which could give you a cup of tea when you want it. Okay, so Tiago is one of the robot that is made by PAL Robotics. So what it's a mobile robot, it's a service robot. What it has is like it has a, and there is a eye for perception. So now the robot is just detecting and moving to it and catching the panda bottle. You see, this is how slow the robots are these days. It's haven't improved much. Yeah, but still like something, right? Yeah, you can see it just took that bottle, it's understanding the person. Yeah. So you saw like how it has worked. So I'll just pause some. Yeah. So you see, it has done the task. To in order to do the task, what all things it had done. So first it understood the cup on the table. See, then it controlled the robotic arm. So there is some kind of controller which was control, because there are motors inside these arms which were controlled to reach this exact point, and there is another motor which was activated to grasp the Fanta bottle. It did, there was some kind of object detection. There is a level of like 3D detection of the position of the this bottle. Then only it will be able to take that. Once that task is done, it should move its base. So now it was in initially it was going this way. It has to turn to this side. So there is a kind of motor at the bottom which was controlled by the robot, and then it detects the human. You can see like it's detecting. It will see it was looking for scanning for the person, detects the person, and move to the person, and gives the bottle to the human, right? So even for a simple task like to take something from the table and give it to the person, there were so many systems, there were so many sensors, there were so many motors, there were so many control algorithms involved in this. But like I'll show you what's the specification of this robot are. So this is a specification sheet of the robot. So what it has is there is a RGB camera. RGB is a normal camera, D is the depth sensor. So it can detect the colors, as well as it can give a depth map of the object. So depth map means like usually we see everything in 2D, right? But depth is like a point cloud data, so where it will be used to detect the 3D shape of that, or it's a square shape, etc. You can use a depth map of that particular thing to understand that. Then it has a microphone and a speaker, so that like you can talk to it, and it will listen to it, it will do the task you can do. And it has like in this particular application they have a five finger gripper, but like the application we have seen, they have a two finger gripper. So basically the idea is to grasp something, and there is a gripper to do that. And there is a 7 DOF arm. So 7 DOF arm means like there are 7 arms, 7 joints, and it can reach with the 7 DOF you can reach most of the objects in a 3D space. And there is a differential base like where it can travel, it can move on a platform kind of thing. And there is like force and torque sensors. So when you are grabbing something like it shouldn't, so if I'm grabbing this bottle, it should be in such a way that it should should not crush this, but just enough to hold this, right? So there is a some level of torque and force feedback to that. Then there is like USB port. If you want to connect your laptop to that, you can use that, like but they usually work over Wi-Fi also. And there is a laptop tray, you can connect it, like place your laptop. And there's a 2DF head, like 2DF head, like you can move the head, like it can move to the like to sideways and little bit like up and down. You have seen like the head is moving in a, like when the it was looking at the person, right? So it can move up and down, and it can move a little bit to the sideways. So there is a 2DF head. And there is a torso is a body. And there is sonar. Sonar is to like if it's somewhere and has to move back to clear something, it should always look they have, it should have some kind of perception or like some kind of detectional thing at the behind also, so that it won't because these robot work among people, so it should not harm any object or any person that is standing behind it also. So there is a some few sonars. And then they have the front laser also. So for front laser or lidar, so they use that to detect this, like so whenever it's moving, this laser will emit their light to all the direction. And it will create a point cloud, and it can detect like there is a wall in front of it, like there is some kind of object or chair in front of it. It has to avoid that. So all those kind of data it can detect with these laser. Okay. So for this particular robot, we have so many sensors, so many actuators, so many things going on. And but like if you are building a robot, they might have spent like 3 or 4 years to build something like this. Okay. uh, I don't know how long it will take for them. But like if you are building something like this, you don't have that much of time to invest it for like you can design stuff, but how you will integrate everything together to a single system, you don't you might it will be really difficult if you are going to write drivers for each and everything, right? So for that, like we have yeah, so the idea is to how do we make all these work together. So when it's moving, it should understand like it should always grasp the bottle, unless it should it is detecting a person. Okay. So it should handle both the movement, it should handle the torque, it should hold the position of the arm, or it should use the lidar to scan at the same time. It should do lot many things at the same time, right? So there should be some kind of system which will bring all these controls together. Okay. This is what you can experience with ROS or robot operating system. It's not an operating system. It's just like mostly like an architecture where like you can build your stuff. There will be a support of so many like libraries and things like that, and you can put everything together directly in a single platform, so that your components will work seamlessly with the components that are already there in the system. Suppose like you are just building a robotic arm, and there is a force sensor, the you are uh, you just have to design the robot, but the motors control you can add there will be somebody who is from whom you have bought these motors. So they might have a like pros drivers. You will just use the driver and integrate with the ROS, and you will there are like different planning algorithms and link planning algorithms, and when you give a coordinate, it should be able to do the task you are doing. Okay, you want to do it to do. And it has like three major things, like there are interfaces. Interfaces mainly like there are different levels of uh, like visualization you need for the development, like There is this is a planning interface, which is called RVIS. So it's a part of the robot operating system. And then there is a simulators. This is a gazebo simulator. What simulator does is like, even if you don't have a Tiaga robot, you can test all the capabilities of the robot in a 3D environment and visualize everything in a simulator. You don't need to buy the robot, you just have to use the ROS packages of the robot and a simulator like a gazebo. Okay. And then there is like latest advancements like ISXM, etc. ISXM is it's a simulator, but it's a more advanced simulator where you can uh, have more realistic rendering, like the images. So you can see this is a classical simulator like gazebo, but it's not that realistic. But here, like you can see, it's more shadow. The right, you can add more environment and like more objects around this, and you can add like different control algorithms, and you can monitor the temperature, etc. In a better way. You can do all these things in this advanced simulators like iSection. And all these can work with ROS. That's the main beauty. You don't. It's depending on you and your application. You can choose the software or hardware packages that you need. And then like all these robots, like whatever you test in a simulated environment, you can replicate the same in an actual robot also. So suppose like this is a unitary go robot. It's one of the like robot dog you might have seen in many of the videos. Like it's one of the unitary is a Chinese company which makes like good like legged robots. They have a like humanoid versions also. So this robot, like you can program and test this robot capabilities in a simulator. And then once you are confident, like your application is ready, you can move to the actual robot. So that like even in simulator you can do anything. Like even if you did like a double backflip, you like what like it might fail in the simulation, but it won't be costing you anything. You just change the algorithm next time and you can work on that. But if you are trying to do a double backflip on the actual robot, so on the first jump itself the motors will burn, and you probably have to replace the motors or buy a new robot. It's much more like the testing and everything is much more effective with a platform like ROS, where you will have can test things in simulator. Once you are done, you can move to the actual robot and implement your application. And there are various tools and components that are associated with the ROS. Like ROS bring all these things together. So for there are like for development, like for programming, you can use the VS Code that you are using for your Python things. And you can edit things there, or like you can then there is terminals. ROS like works in there are two part to that. So one is like a programming interface, which is like the VS Code, where you will write the program. Once you wrote a program, then you will have to build uh, a package like with the code you have built, which will be done through a terminal. So that like I'll show you like in demo, if we time permits. If you are, I'm showing you demo, I'll show you where you can monitor all the parameters of the robot and command the robot everything directly in the terminal itself. It's a real time control and data and everything you can do with this. So basically the idea is ROS brings all the things together. You don't need to have an expensive gear to test something, and you can use the algorithm that you have developed in a ROS interface. The actual robot, it should do all the tasks you have designed for. And next is like virus. Okay, so there are many uh, companies like which makes robot. They might have their own software. Like if you are thinking about a robotic arm, like UR5 is one of the popular robot. So Universal Robotics have their own like control software for that particular arm. Okay, but still it's preferred to use ROS. Why? Because like they have limited capabilities that you can access in the control interface. Okay, but also like that will be just for that robotic arm. But if you are using that robotic arm as a system, like you have a platform which moves, and you need to put this UR5 robot onto that platform, and both of them should coordinate to do a task, right? If you are simply using this robots development, the software that was provided by the like manufacturer, uh, you might not be able to do all the things that you want to with the robot. But since like there is a ROS package for that particular robot, and there is a ROS package for your like mobile robot, you can just you can put everything together and do the whatever you want, combining all these application. And it's fully open source. Like most of the packages are available for free, and you can use that for all like whatever application you want to build. It's there's a huge community support, and it brings all sensors, actuators, and control systems together, and you don't have to reinvent the wheel. What it means, like if you are just building a sensor, you just concentrate on the sensor and how to test that. To you can just integrate that with a robot manipulator and control that using the ROS. Okay, you don't have to build a robotic arm just to test a sensor. You just concentrate on your thing and just integrate that with the ROS. The rest of the things, you there are better ways to do that inside the ROS itself. So your effort as an inventor is largely reduced, and you don't have to spend so many hours to about like robot kinematics or like object avoidance, etc., to just test something, or like just to showcase the capability of the system you are building. You just concentrate on what you want to do with the in the application. And then there is a big ROS community. There are a lot many tools. There are like for anything related to robotics, there should be some way to do that using the ROS. Because like there are person for object detection, there are libraries for object avoidance, like obstacle, everything you have. Like if you want to add a lidar or like sonar, there are packages for that. You just use the hardware and uh, integrate the ROS packages. They'll work in your system. So this is a great advantage what ROS is giving. And there is like a lot many international events that are happening around ROS. Like mostly there is ICRA, IROS, etc. ICRA is an international conference on robotics and autonomous systems, and then there is like IROS, international conference, and there is HRI, human robot interaction. All these kind of conferences, they are like there you can see your the community, and there is a huge discussions, research, etc., going on, and these kind of things. And there is like it's adaptable and flexible. There is something for all. It means like ROS necessarily doesn't mean like so ROS is not a separate language or anything like that. Okay, in ROS you program in C++, Python, etc. If you are expertise in Python, you can use the Python. You don't need to use C++ always. But if you know C++, you can use that. You don't need to use the Python packages or anything like that. There should be a way to use your skills in robotics using ROS. You don't need to start everything from the scratch, but there are ways you can do it within your capabilities, etc. So it's really adaptable and flexible, and you can choose what you want to do with the application. And its scalability is like it's really used across industry, and it's used in the research applications. There are so many papers coming every week on ROS and its applications, algorithms, etc. You can test all those things directly in the ROS. So and scale, even there are like uh, even NASA is using like ROS in some of their space applications, and even I can build a small robot with the ROS. That level of even if you don't know anything about the robotics, ROS is a good place to start so that you will understand both the programming of the robot and understand the hardware in a better way, and then put everything together to build an actual robot. So this is a great platform where you can test things and explore more in this domain. And uh, so yeah, somebody has a doubt. Yeah.
So what do you run this on? Raspberry Pi or some other computer which you recommend?
Now I'll show you like how to use, like this is the main like where I will be discussing it. Okay.
Okay.
So how to use ROS? So ROS is you can run in a different hardware configuration. You can run in a laptop PC, or you can run that in a Raspberry Pi. You can do that as well. But it's better like for normal use, like you will be running that in your system, like your computer. Okay. And the preferred way is to use Ubuntu, because like there is like ROS packages for Windows, etc., but like they are not as good as what you can do in Ubuntu. So Ubuntu is the platform where the usually like we'll be using for ROS, or if you can dual boot the system to install the Ubuntu, or there is like a WSL, like Windows Subsystem for Linux. That's also a way, or you can use virtual machines. But it's always to prefer to use a standalone Ubuntu installation. You can have both, like Windows and Ubuntu installed in the same system. You can use switch between both based on your requirement. So that will be, and you can install the ROS in Raspberry Pi also, or any, like most of the SoCs support ROS. But like it depends on the application. If you want to run a really high grade image processing application, Raspberry Pi might not be able to handle that level of performance, but you might be able to use something like a Jetson Nano, or like even a normal PC for that application. It depends on the application, but there are ways you can use ROS with this. And for development,
I have just one small question.
yeah.
Sorry to interrupt. Is Jetson Nano the Nvidia's computer?
Yes, it's a NVIDIA's computer. So it's basically a mini PC kind of thing, like, but it's built for this mobile robotics application. So you will have a really good graphical interface also. So GPU in that, so that like because like you there is high lot many limitation if you want to put a PC in a remote environment, right? But just in Nano, it's like more like a PC with all the things that you need. Uh, but in a really small form factor, its a size is really small. You put inside your robot and easily control the robot, and integrate all the sensors and applications in that. Okay, so that's one of the like benefit of Jetson. It's just like a computer, but like mostly built for robotics application, or yeah. Can I run it on Manjaro? I don't know about that, so I haven't tried that. Yeah. And for development tools, like you need a IDE, like to write the code. VS Code is the most commonly used one, and there is as I told, you will run things in Bash, like the Linux programming. Terminator is a good tool to do that. You don't need to be an expert in Linux, like even the system commands will help you a lot to that. And uh, yeah, so you can use those in the like for the development. uh, I think like right now like ROS is mostly supported on the Ubuntu, not on other versions of like not on the other systems of the Linux. You can try like there will be more application going on. So these are just like the common things that we are using. Yeah. Then like we have some of the somebody was pointing out, we have the Docker and GitHub, etc. So Docker is getting really popular these days. Docker is a good tool if you want uh, to try out things, because like one issue, if you are if you have a Ubuntu system, okay, and why Docker is important. Docker is like a container, so which basically creates a isolated system environment within your PC itself. So advantage it will give you is like some of the libraries they'll be supporting just like Python by 2, or it will be some of the libraries won't be available for the latest generation of the applications. But you don't have to downgrade your system just to test something, right? So Docker gives you that virtualization environment where you can install things, do whatever you want. Once it started behaves just like a normal like a system, but you will work mostly in the shell scripting and etc. So it gives you much better control. And also you can make sure like if you're installing something in Docker, it wouldn't affect your system the configuration, so that you know like if you're testing something it won't be messing up your stuff that you have already built. So that's a good like good way to work with the robot, because in robotics you'll be testing a lot of things. You'll test hundreds of things, from that one or two will be the like most suited one for your application. So in order to test something, it might be difficult to uh, use your system install also. uh, as you know like the ROS has even though it says like robot operating system, there are like two major versions. One is the ROS 1, and now the latest generation is ROS 2. Okay. They are like the concept is the same, but some of the commands will vary. It's like the syntax or like the commands you use will vary in the ROS 2. And nowadays like everyone is using ROS 2. So if you are planning to learn ROS, it should be ROS 2 you should be learning rather than the ROS 1. But some of the libraries will still be in ROS 1 only. uh, uh, but to use those libraries you can always use Docker, because the ROS depends on the version of Ubuntu you are installing. The ROS ones you can install in ROS 20.04, but ROS 2 is supported anything above like 22 or 24 like that. Okay, so you don't need to change your system to use a ROS 1 package. Rather than you can use your existing system and use Docker to run the ROS 1 packages. And there is like ROS Bridge. It's like a package which where you can communicate between the different versions of ROS. So there are a lot. You don't have to worry if you are not understanding this. You don't have to worry. Like these are, when you start doing things, you will understand like these kind of problems will come, and you can take up the action. Depending on what you want to do at that time. Okay. And github like it's a good place like you for version control. It's just like the GitHub you have. Okay. Like used for programming, where yeah, you can push the code and take backups, and you can, if multiple people are working on the same thing, everyone can collaborate in GitHub. And now GitHub has the develop like LLM supports also, just like ChatGPT. There is a developer supports from GitHub, etc. So you can use all those things with GitHub. Okay. So these are the, so the summary is, if you want to use ROS, you will start with ROS 2. You need to install Ubuntu, or like you say virtual machine. If you want to try something for the first try with virtual machines, but the issue with virtual machines, it might be a little bit slow, so that's why I always prefer to use install Ubuntu in the system. And then for development you can use VS Code and Terminator or any terminal. I'll show you what's the benefit of Terminator when I'm doing the demo. And for advanced stuff you can use Docker and GitHub. If you have like the first two boxes, uh, you can start developing in ROS. If you and as you progress you can learn other things to develop more in this field. And as I told, like the rows you can programming multiple languages, the C++ or Python, you can use that. These are the main two languages that are supported by the rows. And there is XML also for if you want to define the geometry of a robot, we have something called a URDF file. Okay, so UR, URDF is basically an XML file. XML is like it's a rows and column kind of thing. You can search in internet like yeah, XML file where you link the robot parameters with the 3D, so that like when you run that package, it will use this XML file, that is URDF, to fetch the position of the joints and link that to the 3D and brings the robot in the simulation. So and you as I told, like you don't need to be you just need to learn a basic understanding of the Python or C++, and you can switch back and forth, and you can use both in the same uh, application. Like you have a vision system which works better in Python, you use that, and you have a control system which works better in C++, you use that and bring everything together in a single system. Okay. uh, does anyone have any doubt in this? Okay, I'll just move on to the next. Yeah, so the next question will be we have so many things already told, but how do you learn, Rose? That's one of the key challenge that everyone having. In you can see so many courses like Coursera is offering, Udemy is offering. They are all good places. You can, if you are starting something, they are all good places, but you don't have to pay anything to learn ROS. So ROS Wiki is like the Bible for robotics in ROS. So it's like I can just check. So you can see ROS Wiki. So ROS Wiki, it's a detailed documentation where it will talk about how to install ROS, how to install it, like how to get started, what are the packages, what are libraries, what are nodes. You will get all those. So if you are opening any link, it will have like more links to that. And if you have any doubt or something like that, you can go to the support page, and there is GitHub repositories where it will uh, where you will find the code, and there will be if you face an issue, there could be somebody raised an issue in the same thing, there could be a solution there. You can try that, you can do all these things with this. And 1 second. Yeah, so then like there are tutorials also. These are like from normal to advanced tutorials. You will have, you just like open this and read what they have written, use this code, and then just follow the instruction. There are a few videos also you can follow, and these are all like if you are stuck at something, or if you want to use something with the ROS Wiki should be the first place you should try, because they have a really good platform base. And obviously YouTube is there. There are a lot many YouTube tutorials. So this is one of them where like where they'll be explaining, they'll be using the raw only, but they'll show you how it is done. will be things from the ROS wiki. Uh, this is kind of development in the VS Code only. So like they are building a package. There is a simulation. It's a turtle simulator, etc. There are a lot of videos also. This is just one of the videos, like video library we have, we can use. We can follow any library. It's not necessarily this channel only. So this is just I found in a quick Google search. Yeah, but like Roswik is the main thing you should look for. uh, there you will find the solution for most of the things, or just these days you have the support of ChatGPT also. Just like like I need to build a package on this, it will tell you what to do. You can use that, but you don't blindly follow the instruction they are giving you. Just use it as a teacher, and just understand what is going on, and implement things yourself, so it will give you a better understanding of what all things are going on. Okay. So now you know like what is ROS, and how what are the requirements to learn ROS, and where to start if you want to learn ROS, right? And now like I'll just touch up on few terminologies or like key areas of application where ROS is used. To be honest, ROS is used in every field of robotics. So manipulation, like these are just like technical terms that you can search for. If you are planning to do handle things, like if you want to pick and play something, the task is called manipulation. Search for manipulation packages, or grasping, etc. Grasping, it means like you're touching something just like a normal grasping thing. Those kind of applications are called manipulation. As you can see, this is a ABB robot which is doing the manipulation task. And then there is SLAM. SLAM stands for simultaneous localization and mapping. So it has two parts. Like one is localization, second is mapping. Okay. So what does localization mean is like understanding where you are in a 3D space. We were discussing in the initial stage, right? It should understand the position of the robot inside a building. So that you will be using localization techniques to do that. And mapping is like while it's traveling to a space, it should map the environment it is traveling, so that next time, like if suppose like this robot is now doing the mapping part, and like in future if it wants to move from this point to this point, it it shouldn't go this way. It can just move to this to in a straight line, because it has already mapped that area. So it will store the map, and it will use that map for future navigation. It will speed up things that you want to do with this particular robot. And there is robot control. In robot control, so there are lot many things coming, like there is like multi-body controls, and there are normal control, and there are PID controllers, etc. So these are some of the areas you can explore if you are interested in the robot control part. And then there is like learning. We have so many things like we are using the reinforcement learning, etc. This is Jack Isaac Jim. It's currently the part of Isaac Sim. So you can train millions of robots at the same time in and doing like a single task, or like multiple tasks. So it can master the task it is doing. So in if you're doing this, like the like maybe like most of the robot will fall down, but one of the robot is standing up. It means like it will give the weightage to that particular robot, with the parameters of that robot, and then they'll improve from that. So these are like some of the things that you can do. And there is like LLMs, VLMs, etc., uh, which are getting popular these days. Then we have the perception or computer vision. So this is just like it's used in many areas, like even manipulation. There is object detection. So this is a autonomous car, where like you can detect the position of the people, and it can do the navigation, and you can do all those things in ROS as well. And then we have the HRI or human robot interaction. This is like a figure robot. This is one of the advanced humanoid robots that is there right now. So it can there is a chat gp integration. They have now currently moved to their own llm, and you can talk to the robot and it can do this like task you want to do. So these are just like the in the experimental stages. They will be deploying these robots. They have a collaboration with DNW also. They will be deploying the robot real soon in the coming days. And what will be the best way to learn a robot or ROS is start coding. So there is no other way you can learn robotics rather than trying it hands-on, like by yourself. You don't you might be limited with your resources, like if you are building a physical robot, but like nobody is restricting you to use ROS or any of the simulation stuff. You can learn far more things in here as well. And if you are building your skills in the electronics and machine, like mechanical design, etc., just like what we are intending to do in Yandra, you'll bring those things into this in this coding platform. Then blend both of these two together to have an like really good robots. And you can use that for combine different robots or different application to build that really efficient systems. Yeah, and you just start coding. You don't know anything, don't worry about that. Just start today and you will learn much in like in ROS, like things, the learning is very fast. You'll face so many challenges, you'll just overcome that. Next time you'll face something, you'll know like this is the way I should debug things. You just follow that, and you'll get really good with the coding. And uh, that's it. So thank you. So if you have any questions, you can just ask me now. Is there any questions in the chat? Yeah, you can just.
You can directly ask, guys. No need to raise hands.
Yeah, I wanted to know for the simulation part, if there are multiple sensors like camera and all. So if whether I can simulate them as well, like how can I give the input?
Yeah, you can use the simulations as well. I'll show you an example. So, 1 second. I'll show you a demo actually. So, I'll show you like what a normal ROS package will look like. Yes, okay. Yeah, so this is a workspace. In when you are developing something, you will create a workspace. Okay, inside that workspace, there is a src or source folder where you'll keep your codes and everything. And then these three things like build, install, log, these will be uh, uh, this will be generated automatically when you are compiling something, or like when you are building the package. Okay, and these are the inside the src. Also you can have multiple packages, and you'll use these for your development. Okay, so the your question was how you will use the, like if you have some camera or something like that, how you can use with your simulator, right? So I'll show, 1 second, 1 second, I'll show you. Yeah. So this is a simulator. I'm just opening this. This is a simulator called Stonefish. Okay. So this is running the behind, like the control is running in ROS. Okay. And this in this simulator I just want to test something. So this is a test scenario I have created, in which there is like you can replicate the water and everything in the simulator, and there is like cliff where you can add 3D models etc into this. And there is like this is an object like a wind turbine etc. You don't necessarily need a like lab setup to test these kind of things. And in with ROS also, this is a terminator I was talking about. So in terminator gives you option to add multiple windows at the same time. You can add and like split it vertically and do a lot more things with this rather than a classical terminal. That's why I prefer to use the terminal for the building stuff. And in as a part of ROS you'll have a what do you say, a visualization module called RVIS. It's called RVIS 2 for ROS 2. Is RVIS it was used for ROS 1, but you can call it RVIS itself. When you open that, I'm just opening it. So RVs will give you whatever, if you have added a camera or etc and integrated that with the robot, and if it's communicating with the ROS packages, you usually use topics to do that. And there is a camera, there is a depth camera that I have attached with that robot, or the manufacturer has attached to that. You, if you open this, you can see this is a depth image that robot is seeing. Similarly to that, like there's a sonar also. So this is a sonar reading from the robot. Okay. So if it moves like these values, like the visualization things will move. And similarly, if you have a normal camera like RGBD camera attached to that, you will get same kind of image in your topic also, and you can use that for whatever things that you want to do. So it will give you can visualize things. You can, so this is Stonefish where I have built this application, but like you can use the same in Gazebo. Gazebo is one of the default one that comes with the uh, ROS. You can use that also. So I use this Stonefish for the, like if you see like the water properties etc, these are getting simulated in a better way in this. You don't get that much visualization properties in Gazebo. So every simulator has their own expertise. So this is what I have shown you. Yeah, so the point is, yes, you can do visualize your camera and everything, hardwares, everything in ROS itself. Yeah.
Yeah, I also wanted to know, like, if I am simulating something and then I know it works, so is there a way to calculate how much computational power is required for my robot? Like, modern SBCs have tops or something like that. So can
Mhm.
I know what will be the requirement of my robot?
It won't like tell you a particular this much stops should be there, but it's all like based on the experience you can choose something. Because like you are building, you're running something in a 4080 or 4090, and if it's giving you, you can always look for checks like FPS or like the frequency etc. uh, i- i- so in a 4080, if the your application is giving only a 15 frames per second, it means like you won't be able to use that in most of the deployable systems. You need to make your code more efficient to handle a real-time visualization of the things. Okay, so it won't let you like give you a like hard coded value, this is the thing that you have to do. but it's based on your experience. You can either like there are different ways to do that. So you don't necessarily, if you are building a image processing system, uh, and you want to deploy it, and you when you tested it, you found like you are getting really low fps, you can change your algorithm to something else and test it. It might be giving you 100 or 120 fps, and that might can be deployed in a normal soc, which might give you like 30 or 40 fps, but that is enough for that particular application. But or else like you can go for an really high end system. You can put like 2 3 gpus and makes the uh, it might be possible in that way also, but it's up to you whether you want to make things more efficient or you want to use more hardware to save time. uh, you can choose. It gives you, ROS will give you a way to test all those things. Okay, how it will behave if you are deploying this in a raspberry pi, how it will behave if you're deploying that in an i5 system. You can test all those things uh, in your limited environment itself. Yeah, that's the main point you'll be getting.
Yeah, thank you so much. Actually, I had one simple question. Actually, I'm currently building a autonomous UAV
Mm,
that should be able to track vehicles and detect objects and avoid them. So
mm,
there are two approaches that I am planning. The first approach is to use the 4G internet and
mm,
transmit the video feed and everything to my computer, and then process the and ROS will handle everything from my computer. But there
mm,
is a problem for the delay. If the delay is too high, so my UAV won't be able to won't be good enough for like stabilization or something
mm.
at that way. So the second approach is that to use a powerful computer like Jetson or Iron Nano or something like that on the
Mm.
UAV itself. So I don't know which approach is the best for me.
I think like you play a little bit. My suggestion will be to play a little bit on the algorithm side rather than going for a Jetson right now, because like you can, for algorithm you can always invest a little bit more time. Even if like you are working on that, you are getting a 30% improvement in your current system, and if you are putting that into a Jetson, there is a huge advantage you'll be getting, right? So it's always try to optimize the code you have and try to limit the frames per second. Like in most of the cases you don't necessarily need all the sensor data at all the time, right? You can limit the sensor data and put counters for that. And suppose like for gps, you don't need the gps at 1 millisecond time limit. Okay, you can get it like once in 3 seconds, 4 seconds, like that. Okay, but for if you have a lidar, but for that you need to have like continuous data. So you can prioritize the sensors and play a little bit with that, and you can play with some of the algorithms you are using. uh, Usually like there could be like reinforcement learning or those kind of algorithms which might be able to do the thing that you are targeting to do in a better way. So you can try those also. And still if you face an issue, there could be you can try with a better hardware and move in that direction. No.
Yeah, okay, sir, got it.
Yeah.
Yeah.
There are some question in chat also. Mm, wait. Who is there? Can we use other sensor also like accelerometer, etc.? And don't know.
Yes, yeah, you can use like with accelerometers. You can use that with your Arduino or Raspberry Pi, etc., and use that integrate that with your ROS. For Arduino, there is a ROS a serial connection that is coming, so which where your system will be able to communicate with Arduino that you're having in the Arduino IDE itself, and that's a way to do that. Or if you want to integrate that as a part of the system itself, you can do that as well.
Okay. And one more question is there. Can I simulate a 3D printer here in ROS? I need it for project to try different variations or something. Yeah.
Yeah, so basically, the 3D printer is a Cartesian robot. You see, it's a robot where like it can move only in X, Y, Z direction. You can use that, definitely build your robot or a 3D printer. If you have a 3D model of that, you can integrate that with the ROS and test various patterns, more efficient ways to do that. You can do all those things. Yeah.
And okay. So last question is, would you share the PDF?
Yeah, I can share the
Asking you.
PDF. Don't
Okay.
worry. Uh,
Any more doubt, guys? You can ask. Okay. What other simulator which we can use?
Other simulator, like if you are the latest ones are like the Isaac Sim is one of the advanced one, but Isaac Sim there is limitations in terms of hardware, because like if you want to run Isaac Sim smoothly, you need to have at least 8 GB of VRAM, which is possible probably available in 3070, 3080 and above. Uh, and yeah, you can use that. That's one of the advanced simulator where you can test a lot more things. Like Isaac Sim comes as a part of Nvidia's Omniverse universe, okay, where there are other integrators like for digital twins, etc., and there is the some special modules for humanoid robots also to integrate everything there. So Isaac Sim is one of the option. Other simulators you can use like a Gesiba, as I told, like Gesiba is one of the really common one that is used. You can just check for the your particular application and choose a simulator uh, according to that.
Okay. And one more
Sir,
question is there. Just one second. Any other ROS alternative? Why ROS is like more popular than others?
There were few other alternatives for ROS, but like the community has grown in such a way that like it's easier to work with ROS. There are a lot more support, lot more libraries, packages, etc. That are readily available in ROS. That's why ROS is more popular uh, these days. You don't have to spend so many hours to work to develop a system which is readily available in ROS. You just start it and just use a package and just build, concentrate on the application. That's why it's really popular. There are like if you want alternative ROS, like most of the a robot manufacturer will have their own SDKs. That's a way to program the robot where it will just communicate with the robot controller or driver, and you will use that in that way. Other options will be a TCP connection, like in some of the application, like you can like just like sending ones and zeros, you can use that to for the actuate the robot. That's also different ways to do that. It's all depends. TCPs could be is a really faster option because it doesn't need to think about anything, but it's really difficult as a programmer side of if you are doing the development. But ROS will makes your life easy if you are opting for that.
Yeah. And one guy is asking something. You can ask maybe.
yes. Sir, so what are the limitations of ROS? Are there any limitations for it? And
Uh, yeah. So yeah, ask me. Yeah, I'll.
yeah, primarily regarding the distributed computing and ROS.
One of the key disadvantage of ROS is like the packages are varying a lot. To finding the stable package uh, is like slightly challenging. But once you made it work, so the system tries to be stabilized. One thing is like instability, because it's an open source one. There could be like some bugs which might not be addressed. So that's something that you should be aware of. You like in some cases, like you'll be spending so much hours in fixing an issue like that, you think like it's because of the something that you have written or algorithm or something like that, but then you realize it's a issue the package or the robot controller or anything like that. So that's one of the thing that you should be aware of. And like other than that, the good thing is like you have a good community where you can ask questions, you can chat with people. There will be other people who have worked in a similar system, you can check with them. Suppose you're driving and if you are building like autonomous car, okay, there should or autonomous boat, there will be another person who has worked on an autonomous car. You can just if you are just looking for the vision system, you can discuss between both and build make your system more efficient. So that's a way to do that. Yeah, I think that these are some of the key disadvantages, which is like the instability. Other than that, one thing is like some of the, so if you're thinking about the really high-end robots, they might not be making their system open source. Okay, so if you are planning to work with really advanced humanoid robot, they might, so since this it is their own patents and things like that, they put on restrictions to, or they might not even release a ROS package for that robot. So in that case, it might be difficult to control the robot with the ROS. So that's some of the, but there are different ways to do that, but it's not a straightforward thing. And sometimes in the sense integration, in many of the things might work in the simulation, but you might not get the same level of performance in the actual real world. So you have to do this, you have to go back and forth between the simulator and the real robot very often, so that the complete system works smoothly in the actual application. These are a few things that I experienced.
Yes, sir, got it.
Hello,
Yeah, yeah.
sir. As an undergrad student, so if someone working on converters or motor drives, so what level of converters, like linear or non-linear or large signal model converters, which level of converters will be good for their like placements or for their future studies?
Converters, I'm not an electronics guy, so I didn't understand your question. Converters, like, what do you mean? Like drivers, developments, those kind of things. Or
Yes, sir. Motor drives.
uh, I think like I don't know. So there is a demand for everything. So it depends on your interest. Okay. So if you want to, so if we are building for heavy motor drives, they are really used in like high voltage industries like automations and those kind of applications. Whereas the small ones are really like getting used in like robotics, and there are more small automation systems that are coming. There is a demand for all electronic stuff, but depends on which field you want to be. And also in industry, these all varies a lot. You should be able to adapt rather than just sticking to a particular thing. I should don't focus, tell like I'll always do this, then like don't be in that mindset. You should be open to adapt. You should be a constant learner. And in industry there is no, so I basically I was a mechanical engineer, but I'm working on mechanical engineering, mechatronic stuff, sensors, actuators, robot programming, all those things. because in industry that is you are all like developers or engineers. You just think about an idea and do whatever it takes to build that idea into reality. So you should learn new skills. It's a fun thing to do that, and that will develop your skills also. Just be open to learn, and you'll go far ahead than to stick into a particular thing uh, throughout your life.
Yes, sir. Thank you.
There
Uh,
is, yeah.
there are two more questions in the chat. So one is, so we need VRAM in hardware or robot, or we can do computation in laptop and then transfer data to our bot.
Usually, the robot is connected to a laptop or PC continuously, or like it could be a wired connection, it could be through the Wi-Fi or etc. So, in most of the computation can happen in your laptop. Like this is like in my perspective as like a robotic developer, but in deployment there could be different ways to do that. Like you can build a really good system within the robot itself so that it can do everything autonomously without like looking to anything any other thing. Or like if you want to build a cheap system, you can use cloud based connectivity and do the computation there. There are different ways to do that. uh, so if you're looking for do we need like VRAM in hardware, like depends on the application. uh, for normal robot, like we're building a robotic arm or like something like for navigation etc, you don't necessarily need a really high VRAM. But if you're building like image processing system, you might need that. It depends completely on your application. uh, and it could be a part of the robot. It's also depending on your application. If you want to deploy a robot in the Mars, you cannot rely you need to put everything in the robot itself. You cannot send something to Earth, get it sorted and send it back. By the time your robot will be falling off of the cliff. Okay, so there could be depends completely on the application what you need to do with the system.
Okay, last question is there. What's the difference between ROS 1 and ROS 2? This is the last question, right, guys? We
Yeah,
have to
I
end the session
already told
also.
us ROS 1, ROS 2 are like uh, mm, uh, they works the same. Only like ROS 2 has like more security and those kind of features added to that. And as a developer side, the way you build things is slightly different. Like one of the it's a good thing also, because like in ROS 1 everything has to be a part of a particular package only. You like you have an image processing algorithm, you have to you like it has to be a part of your package itself. But in ROS 2 you can make that like independent. It means like there is a image processing algorithm which is giving you like a filtering image and giving you the feedback, and there is a control algorithm which is going to fetch this uh, and use that for an application. In ROS 1, whenever you are building a robot, you need to put this image processing into that like into the your package itself, so that then only it will be able to communicate. But the ROS 2, you just have a common image processing system which you will use that for your different robots. They because they all will be doing the same thing, and then the control part only you can vary it depending on the application. For a normal user, like for a developer point of sight, there are few changes in the commands that are using. Like you were using like catkin make in ROS 1, but you'll be using Qualcomm build in ROS 2. These are just like the algorithms, not like the syntax, but the way we work is more important, which is similar for ROS 1 and ROS 2. If you're looking to learn ROS, it's ROS 2 should be the the thing that should which has the future, that should be the one you have to learn. But there are like if you have a really old robot, so uh, there is ROS inside robot also. So if you have a really old robot that might be working in ROS 1, and in that case you might want to program something in ROS 1, or like you can use ROS 2 and use a ROS bridge. So there are different ways to do that as well. So these are some of the things, the main differences between ROS 1 and ROS 2.
I think done,
Yeah,
guys, right?
yeah.
So
We
please,
have
I am handling over to Muskan, please.
Yeah. So, guys, today's sessions was very interesting. I hope you understand something new about robotics. You are very lucky because Finny took your session, and so Finny, thank you so much. Take our session.
And
thank you guys.
thank
If
you
you
from
have
my
any
side
doubt,
also,
like
Finny. So I can tell like he is also part of our club. So if you want to interact more with him, you can just text him in the group. I just shared the
yeah.
link also. Yeah, you can join and just interact with each other.
Is that
Okay.
WhatsApp group?
What?
Uh, yeah, you can. There's a WhatsApp group for Yandra. You can just
Yeah,
ask
I am
through that.
resharing all the links. Wait, I'll just reshare. And
We
from my
have
side, thank you.
Discord also if
Thank
you
you so
want to
much.
post something.
Yeah, we have Discord also. We have Instagram, Facebook, whatever social media we have all. I think so. Muskan is only handling these things, so she knows what the account we have. So yeah, okay. I'm just stopping the recording. Okay.